Hello and welcome. This is Scott Daniel offering a presentation on deploying artificial intelligence, machine learning in production. First thing I want to point out before I begin the actual presentation is a disclaimer. All the opinions that I'm going to be presenting to you are my own. They do not necessarily reflect the views of any of my past employers, clients, organizations, people, pets, or anything else I can think of. So if it's something that you disagree with, it's probably something I came up with on my own. Thank you. Continuing that same disclaimer, these are some of the clients I've worked for in the past, just to give you an idea of my background. IBM, Mercedes-Benz, Booz Allen Hamilton, Bristol Myers Squibb, Audi, Wells Fargo. Let's start off on why we're having this conversation in the first part, which is to discuss a little bit about the promise of AI. Why is artificial intelligence talked about so much? Let's review some quick facts. The market growth for AI will accelerate at a cumulative average growth rate of over 33% over the next few years. The incremental growth between 2018 and 2023 is supposed to be $75.5 billion. The year-over-year growth estimate for 2019 is estimated at over 29%. Unfortunately, you'll also see that the market is fragmented, with several players occupying most of the market share. 61% of the growth is originating from North America, although you'll also see that China is coming on strong. One of the key drivers for this market will be increased employee productivity, the theory being augmented intelligence, which is the topic of artificial intelligence that's used to assist people in getting their jobs done. Now, AMC Laboratories has a bit of a different take, but the same basic idea. A growth rate of $118.6 billion forecast for global AI market by the year 2025. So as you can see, that is a ridiculously high amount of growth, and one of the reasons why there's so much attention to the field. Let's also take a look about what Accenture, the international consulting company, has to say. They're arguing that artificial intelligence is actually the future of growth itself. The conclusion essentially is, if you're going to have any key driver of growth that you're going to monitor and capitalize on, it's definitely going to be artificial intelligence. Now, if you combine this with some research that was done about 5-6 years ago by a company called Nucleus Research, they found that the return on investment for typical analytics project is between 900 and 1200%. So in other words, if you put $1 into artificial intelligence, specifically analytics for business, you're expected to get $9 to $12 back for every dollar you put in. I don't know of any other technology that can provide anywhere near this amount of growth, which is one of the reasons why there's a lot of focus on it. Now, this is a scary one, but it gives you the idea of how much the general public has become interested in this. If you look at this ad from an investment site, which I'm not going to necessarily suggest that you go to or use a whole lot, artificial intelligence share to invest for huge profit. When you start getting into the public mainstream to the degree that they want to try and sell you stocks or investment based on artificial intelligence, you know that the general concept of this is caught on. So how are people supposed to get there? What is the method by which artificial intelligence is supposed to provide all of this profitability? How does it work in an ideal world, at least? If you'll start with the upper right-hand corner, where you'll see this graphic with the 5 chevrons, you go from data to analysis. The analysis gains insights. The insights provide recommendations on which actions to take. And then the actions drive the value. Now, this is really important. A lot of folks in the data science community are really into the first 3. Excuse me. They want to be able to identify the data. They want to be able to do their models. They want to be able to do all types of analysis. They want to run their Python scripts. They want to build all these pipelines. All those things are great. But unless the insights make it to the action channel, those insights are relatively useless. If I can't take advantage of what I've learned, then what I've learned doesn't have a whole lot of value. This is also going to come back to play in a conversation we're going to have shortly. Now here is a diagram that was actually created by the software company SAS. They broke out the following wheel in terms of the process that you're supposed to follow. First, you identify or formulate the problem. Next, you work on the data preparation. These are all the steps for data cleaning, all the things that most data scientists don't really particularly like to work on. Data exploration, so this would be EDH, or EDA, exploratory data analysis. Then you're going to transform and select the final variables that are going to go into your model. You're going to build the model. You're going to validate the model. You're going to deploy the model. And you're going to evaluate and monitor the results. What most of the press likes to focus on is here, building the model. They're very big on telling you which algorithm you want to use. They're very big on saying that deep learning is the solution to everything. Hint, it isn't. But that is where a lot of their focus is. So what I want to do is warn you that actually where the wheels tend to come off in this process comes from these three on the left, and specifically the deployment and the monitoring of the results. Now we're going to talk to what I refer to as the yawning gulf, also known as the yawing gulf. All right, so we just talked about all this growth in artificial intelligence and all the benefit that it's supposed to be able to provide us. But what we're going to see now is there are a lot of headlines out there that indicate that this isn't actually happening. Take a look at the big data ROI failure rate from an organization called Barn Raisers. Where is the big data ROI? Now notice the date on this. This is going all the way back to 2015, when the hype cycle was really starting to kick into overdrive. They were saying early on that all the push towards big data itself wasn't really providing a lot of return on the investment that folks had put in. Then let's look at the AI failure rate itself, in terms of not just the big data, but AI as a whole seems to be falling down on the job. Notice the statistic. Why do 87% of data science projects never make it into production? That's a ridiculous failure rate. It's huge. Why is it so high? I don't know of a whole lot of industries or technologies that can survive on just a 13% success rate. That's horrible. But that's not the only headline that seems to be indicating this. Research from Gartner indicates 85% of AI projects will not deliver for chief intelligence officers. Okay, so what is going on here? Gartner holds one of the biggest conferences in the country on data and analytics every spring, and they're finding that 85% of the projects from the clients that they research aren't making it. It doesn't seem to be getting any better. As of March the 2nd of 2020, you've got another article, this time from an organization called Designing for Analytics. 85% of data science projects fail. What is going on? Clearly, there is a ridiculous gap between the promise of AI that we talked about and the actual reality of what's going to happen. So let's go back to the diagrams that we just talked about a moment ago. Notice on the top right, you see these two boxes for action and value. This is where things seem to be falling apart, which is also these two boxes in the circle diagram we just mentioned, deploying the model and evaluating the model, and the text version down here in the lower left-hand corner. Yet this isn't what people want to spend their time talking about. There isn't a whole lot of press out there on deployment, which is why I'm really glad that there are now conferences that are being able to address this topic. So what I'd like to offer is just some top 10 artificial intelligence deployment tips to help you navigate through the process and actually make it to the first group of slides about the growth and the promise of profitability from AI, as opposed to having the issues with 87% or 85% of the projects never making it. Tip number 1, I want to take you back in time to the year 1989. The most popular business book ever written was by a gentleman named Dr. Stephen Covey. It was The 7 Habits of Highly Effective People. If you're as old as I am, you will remember a time where you could not escape The 7 Habits of Highly Effective People. It was the first nonfiction book ever to sell over 1 million copies and is still the best-selling business book in history. Just an amazing accomplishment. He laid out 7 different habits that would allow you to be a very effective manager. And the second habit was actually pretty simple, but it applies very much to implementation here. And it was called Begin with the End in Mind. What he meant by that is when you're designing a project, especially an artificial intelligence project, it becomes so easy to get wrapped up in all the excitement, to become entranced with what algorithm am I going to use? How am I going to present the results? What technology am I going to implement? The infamous R versus Python debate, or maybe now we have to put it in Scala. All those things are important. But when you're making those decisions, it's really easy to get caught up in the minutiae and the trivia. Instead, what you want to do is to think, for every decision that I make, how is this going to implement the actual end result? Or another way of thinking of this is to use the phrase, project the future into the present. If I was doing this right now, in this very moment, what would be the best option for me? If I actually had the model in my hands today, it was all finished, all the fun stuff is done, what would I be doing with it? Would my data look the same? Would my implementation path look the same? What technology would I be scoring the records with? What type of KPIs am I going to have on the performance? Start with those things first when you're laying out the plan for how you're going to get your project in place. Tip number 2. This is a really easy one to skip, and it's not a good idea. Identify your stakeholders' needs and goals. I have a hidden secret for you. Artificial intelligence and models are about people, not about technologies. Again, everyone wants to talk about the algorithm, but take a look at all the stakeholders you have to be considering when you're developing a plan for implementation. You've got regulators. By the way, folks, are you aware that if you're in the financial services industry, any type of a neural network is likely to get you in huge trouble with the United States regulators, at least? Most of the techniques are very hard to implement and meet with scrutiny. Basically, what they want you to be using is some version of linear or logistic regression or a scorecard, maybe a decision tree. Most of the popular functions that people are always talking about, such as random forests, neural networks, deep learning, you can't get them into place. Environmental partners, maybe not so much. However, there is a big push now with companies arguing against large tech companies building ridiculously large models because they require ridiculously large data centers. And ridiculously large data centers use a ridiculous amount of power and add to the carbon footprint. Bet you didn't see that one coming. Community groups, especially when we're talking about the topics of fairness and bias in models. What steps have you taken to be able to make sure that you don't have bias in your models? Think that through before you build your model. Don't try and slam it in at the last minute. Local authorities. Who needs to be notified about your project? What other things that you have to do? Is this going to cause local folks to lose jobs if you're going to outsource this to a different country to be able to implement? Etc., etc., etc. I could go through each one of these and go through the same type of process. But the trick is when you're laying out your plan, you need to identify what your stakeholders want before you start building the models. Especially when we talk about customers and employees, think internal clients. How is the person who requested this model going to measure your success or failure? How is that going to be done? How are they going to implement it? What do they want? It's fantastic to you if you get an increase in the ROC of your project of 0.2%. If your client needs to have something in place by next Thursday, they may not care so much about that. Time may be their critical element. You need to know these things before you sit down and start building the model. Tip number 3, identify model and project constraints. You'll notice that tip number 2 is finding out who your stakeholders were and what their concerns were. But how does this limit your project? I took this slide out of a project management site, projectmanager.com. The 10 constraints of project management. Is it sustainable? What about your organization? What method are you going to be using? Who are your customers going to be? How much time do you have? What's the cost going to be? And what is the potential cost savings or increase in revenue on the other end if the model works correctly? Scope. They're going to want to make sure that you're not boiling the ocean to be able to get this out. Quality. What are going to be their measurements of quality, and how are you going to have the model compare on that? Do you have reporting to be able to show it to them that that's true? Risk. What happens if your model goes down in the middle of production? Do you have a backup? What happens if the model actually scores backwards? No, I'm not kidding. That has actually happened in projects I have seen with clients implementing. The model scores upside down, so if they're trying to find customers, they actually end up predicting non-customers and end up driving an organizational project into the ground on a financial basis. Resources. What if you've got a company that is only using internal resources and refuses to use cloud-based sources, but you want to use AWS for building your model? You have to figure that out on the front end. Tip number 4. Phase gate approvals. Now, the diagram here is helpful if you ignore this top level of labels that you have here. Phase gate actually came to me when I was working on project management, product development for a financial services organization. And the basic concept is this. For each stage in your model, you're going to want to build a gate. And the gate essentially says, do we have sufficient performance to go to the next stage or not? You must pass all the criteria for the first gate before you get to go to stage 1. To get to stage 2, you've got to pass by the criteria in gate 2. Gate 3 is required for stage 3, gate 4, stage 4, session, so forth, all the way to the end. What you want to do is to make sure that you have all of those gates in place and identified what are the criteria that allow you to get from step 1 to step 2. Let me give you a quick example. Let's say that you're going to predict the results of a particular stock in the stock market on a given day. What data are you allowed to use, and will the data be in-house? I worked for a very large financial services organization that was trying to predict the stock price. Let's call it stock A. And the idea is that on Monday, they would predict what the stock result was going to be for stock A on Tuesday. Fair enough. So I worked with them and I looked through the data that they were planning on using. Well, one of the elements was, what is the overall performance of the S&P 500 for predicting that stock price? Unfortunately, they were using the overall stock market performance for Tuesday to predict Tuesday's stock price. Well, the problem is they wanted to make this prediction on a Monday. So on Monday, you don't know what the stock price is going to be or what the overall S&P 500 is going to be on Tuesday. So you can't use that model using that data element. You're going to have data leakage. So you have to go ahead and make sure that you've accounted for that on the front end. And in this particular case, if you had a gate that indicated whether you could use that data or not, you'd say, no, that's not going to work. We've got a data leakage issue. You wouldn't allow the project to continue forward through all these other stages and waste a lot of time and resources because it wouldn't get through the initial stage that said, let's make sure our data is going to be available. Tip number 5, planning for obsolescence. This is one that I see so many organizations fail at. You have to understand that all models are going to drift or decay over time, and you need to plan for that up front. So, for example, let's say that you've got a model that's going to predict the level of sales in retail in a given year. One of the things that you're going to need to monitor is how many people are going to retail stores in that industry over a given period of time. Because as of today, when you're doing your model, let's say that 40% of an organization's revenue is coming in from retail stores. Well, next month, most people may be shifting more and more over to online sales. Well, the model was very good when you built it based on the data that the model had at that given point in time. But as time changes, the environment changes, the data changes. All those things need to be accounted for. And you can't do that up front because you don't necessarily know how the model is going to decay or how much or over what time. So the trick is to know that any model that you put in place in a given period of time is probably going to decay. So if you follow this set of steps that was actually created by the ESCML and reported by University of Maryland, you can actually identify how often you're going to check the performance of the model, let's say every quarter, and how much drift are you willing to put up with. And at what point in time are you going to rebuild the model based on data that's refreshed? Plan that on the front end. Make sure that your internal client knows that this is likely to happen and you need to be prepared for it. Don't go into a situation where your client is expecting that everything is going to work just fine and then sort of spring this on them at the end because they're not going to be very happy. So put into your plan how often are you going to measure, when are you going to update the model, and what is your swap out process. Tip number 6, plan around the analytics maturity model. Now, look, I know everyone and their cousin Sally seems to have an analytics maturity model, but the one I'm going to use is going to be from Gartner. So essentially, an AI maturity model says, what level is your organization in for implementing models? If, for example, you're in a very small company, or you're just working on level 1 awareness, you're just trying to get your organization to understand what artificial intelligence is, or when to use it, when not to use it, all those types of things. They don't know a whole lot. They don't have a whole bunch of models in place. If you're in this level, you do not want to be putting in a model that's really overly sophisticated, or that's going to have one that's going to have a low explainability level. Why? Because it's going to be very hard to get internal buy-in. And there's a high chance that people are going to get confused, they're not going to understand, and they're not going to implement the model correctly. As opposed to, let's say you're on level 5, transformational. You've been putting AI models in forever. AI is considered part of the business DNA. You have a regular schedule for models. You have models in every single department, all sorts of processes. Here, you may be willing to put in a more sophisticated model or a model that has less direct explainability because there's a comfort level in the organization. But you need to make sure that you are matching what your implementation complexity is going to be to the level of your organization. In the beginning, you're going to start with simpler models. You're going to start with things like logistic regression. You're going to start with things like decision trees. You're going to want to make sure that there's a high explainability level. You want to get everyone comfortable. You want to get buy-in. That's very different than if you're an organization that's been working on deep learning models for the past decade and they actually have AI as part of that DNA. Tip number 7. Validation overkill. Now, let's all take a step back. This is probably more steps in validation than anyone really needs to have. But the reason why it's set up this way in 7 steps is the fact that you want to be building trust. Trust is going to be the currency that allows you to be successful or unsuccessful in your organization. So you want to provide more levels of validation than really ought to be necessary. Not so much that it's going to impact the model, as it's going to impact that trust level, and to make sure that the wheels don't come off, so to speak, as you're going into implementation. So here are the 7 stages I recommended for one of the organizations I've worked with. 1, have a holdout sample validation. Break your original data set into a test and a training set. Only build the model in the training set, and then only report results on the test set. This will make sure that the model is not overfitting or essentially memorizing the answers. Step 2, cross-validation. You're going to take, let's say, 5 stripes of your data. 1, 2, 3, 4, 5. And for each one, you're going to have a bunch of green stripes of your data and one pink stripe of your data. So in this case, each one of these little blocks represents 20%. You're going to build your model on this 80% of your data, and you're going to test the green, and then you're going to test on the pink one. For your next attempt, you're going to go through and you're going to change which block becomes the test group. This is extremely valuable for preventing the impact of overfitting for your data. Also works extremely well for smaller data sets. It's extremely useful to also combine the results of each of the individual models together and come up with voting on what the correct answer to your model is going to be. So that's cross-validation. 3, holdout time frame validation. This is extremely important if you're doing stuff like time series, but also if you're doing a longitudinal study, let's say over the past 3 years. You're going to want to hold the most recent time period, let's say a quarter, your most recent quarter, and don't make it available in the actual model building period, because you want to see if time elements have shifted things in your data that will change the results of your model. So this is one that you're going to do all the way at the end of the process after you've completed validation steps 1 and 2. 4, silent validation. All this means is you want to make sure that the model on a daily basis can produce a score without doing anything with that score. So for example, you want to make sure that a score is created every day, that you don't have missing records, so you don't have any operational issues, that you're able to read the scores, that it makes sense, that the representation across deciles is the same. Basically, this is your operations check piece here. You do this in silent mode, meaning that you're not showing those results to anyone else. You're making sure that the piping, so to speak, in operations is working so that you don't announce it to the organization and then find out there's a problem and then have egg on your face. Step 5, recruit validation. Who's going to be using this model? For example, if you're going to do your model with a sales team, you may want to take a group of recruits. You want to work with those recruits, find out who's willing to test out the model and see if the results hold up. What are their comments? What are their concerns? You want to make sure that all those are taken care of before you move to stage 6, which is rollout validation. Rollout validation tends to happen right after someone does step 1, a holdout sample validation. And that's where a lot of your implementation, the wheels are going to start to come off and you're going to have big issues that you're going to have to address. You want to make sure that you've taken care of these steps as much as possible. But the rollout validation is going to say in week number 1, let's say of a given month, we're going to roll it out and see what happens. And then we're going to rest the model during week 2, fix anything that's wrong, and then continue the rollout. Step 7, non-stop optimization. This is basically a silly term, but essentially it means you're never done validating your model. Things are going to change over time. This is where you put into the steps that we just talked about in terms of preparing for model drift and that you're going to have to replace the model. Over time, you may continually want to be able to improve the model, test it, update it as needed. Step 8. I have the hardest time with most people getting them to understand and buy into this concept. Simplicity and flexibility are your allies. Complexity sows the seeds of its own destruction. Don't make a model more complex than it has to be. Don't make it harder to understand than it has to be. Don't make it take longer than it has to be, either in development or in scoring the final results. If you have to make a decision and it's unclear what the final impact on the model is going to be, stick with things that are simple and flexible. Step 9, create a champion challenger testing approach. Now, what I mentioned earlier a couple slides ago was you may have a situation where you have to update a model because you've had model drift or some other type of issue. Don't just take the first model and throw it away, stick in the second model and hope for the best. You want to have a process in place called champion challenger, where you have model A, which might be the existing model, and model B, which might be the new model, and you want to compare the results between A and B, which is working better. You may find that the new model that you just built on the new data isn't working as well. You're not going to be able to find this out unless you have scores from both models at the same time. You want to make sure that this is taken care of before you permanently replace any model. Make sure that you're getting results from both models in production before you decide to get rid of the old model. Last, what is your undo plan? So many organizations don't think this through. Always, always, always test your undo plan. Don't just have an undo plan. You need to test it. How are you going to get this model back out of production? If you take the model out, are there other processes that happen downstream that are going to be implemented by this? What's going to be the impact of that? You need to be prepared and to test your undo plan before you put anything into production. That's all I have for today. If you have any questions, please let me know, and I'll do my best to answer them for you. Thank you so much.